This is Mr. Gillum, and today we're going to be talking about common factors and multiples. This is on page 102 of your instruction book. It says that Matt is running for student council. His friends are going to help him give out 15 posters and 6 banners. All of his posters and banners will be packed in boxes. He wants to put the same number of posters and the same number of banners in each box. What is the greatest number of boxes that Matt can pack? So it looks to me like he has posters and banners, and he's going to pack these in boxes. Okay, there are 15 posters and 6 banners. He wants to have the same number of posters in each box as the same number of banners in each box. And so for part A, it says that you know that Matt wants to pack the same number of posters in each box. So we're just considering the posters right now. Okay, there's 4 ways that he can pack 15 posters with the same number in each box. If he packs one box, he can put all 15 posters in the same box. That's one way he could pack them. He cannot just pack 2 posters in each box because he would have 2, 4, 6, 8, 10, 12, 14, but then one box would have 1 poster because 2 does not go evenly into 15. So he could not pack 2 posters in each box. If he uses 3 boxes, he could pack, so if he wanted to put all the posters in just 3 boxes, he could put 5 posters here, 5 posters here, and 5 posters here. And then we met the criteria of the same number in each box. So he could do 5, 5, and 5. So that would take 3 boxes, and each would have 5 posters in it. I didn't know I could even move that. There we go. If he uses 5 boxes, then each would have 5, 10, 15, 3 posters in it. Okay, and I can draw a picture for you there as well. 1, 2, 3, 4, 5. If he used 5 boxes, 3, 6, 9, 12, 15. And then if he uses 15 boxes, each would obviously have 1 poster in it. Any of these different situations would be plausible for just the posters. Okay, we call these factors. The factors of 15 are 1 times 15 or 3 times 5. The factors are what told us the different ways that he could pack the boxes with the same number of posters in each box. It says he also wants to pack the same number of banners in each box. There are 4 ways to pack all 6 banners. So again, I'm going to use the same strategy. Before I get started, I'm going to think about the factors of 6. Will be 1 times 6 and 2 times 3, right? And that's how I write my factors. I kind of go from the outside in. If you just use 1 box, he would just pack it with all 6 banners. They would all go into 1 box. That would be fine. They would all be in the same place. If he uses blank boxes, he will pack each with blank banners. What if we did 2 boxes? If he had 2 boxes, each would be with 3 banners. 2 times 3 would be all 6. If he used 3 boxes, he would pack each with 2 banners. Or if he used 6 boxes, he would put 1 banner in each box. Any of these scenarios would work for just the banners. We need to find a scenario that's going to work between part A and part B, where he can pack the same number of boxes and they will still be equal. So I'm going to be looking at this first row of numbers. Okay, and I'm going to try to find a common factor, one that they share in common. I want to know if we can find the same number of boxes in both of them. Okay, so I'm looking at 3, 5, and 15, as well as 2, 3, and 6. And what I'm starting to see is that maybe if he uses 3 boxes, he will be able to evenly divide them into both posters in the same number of posters in each box and the same number of banners in each box. So 3 is going to be the magic number I'm predicting because that is a common factor between 6 and 15. So it says explain how you could find the greatest number of boxes that Matt could pack that have the same number of posters and the same number of banners. Well, like I said, I see that you could do 3 boxes with the banners, and you could do 3 boxes with the posters. And so if I did 5 posters in each box, and 2 banners in each box, and there would be 3 boxes. Each of those boxes would have the same number of materials in them, and that would be the best way to solve this problem, I think, by finding the greatest common factor. So we could list the possibilities how he could pack posters and how he could pack banners, and see if there are any boxes, numbers of boxes in common. So Matt could pack 3 boxes with 5 posters and 2 banners in each box. So that's what I was highlighting back here. He had 3 boxes. It would work for posters and banners. Banners and posters, posters and banners. Okay. That's called the greatest common factor. Okay. The number of boxes and the number of equal groups of posters are factors. Those factors are numbers that multiply to get to a product. So, for instance, let's do a little example out here on the side, because I want to be very clear about this. Factors are different than multiples. Factors of, let's do a big one like 24. Okay, I would know that 1 times 24. I would know 2 times 12. And you see how I'm kind of going from the ends in so I don't miss any? I could do 3 times 8, or I could do 4 times 6. I know 5 doesn't go into 24, and then I make it back to 8, and I know I've got everything. So if you go from the ends to the middle, if you're making a list of factors, that's gonna ensure that you don't miss any. Okay. So it says the number of boxes and the number of equal groups of banners are factors. The product is the total number of banners, 6. In Explorer, you listed all the factors of 6. When you found the greatest number of boxes that Matt could pack, you found the greatest common factor of 15 and 6. The greatest common factor of any 2 numbers is the greatest factor both numbers have in common. If the problem on the previous page, you found that 3 is the greatest common factor of 15 and 6. You may want to organize your list like this. 15 and 6. The factors of 15 are 1 and 15. 2 does not go into 15, but 3 goes into 15 5 times. You see how I'm going from the ends to the middle? 4 doesn't go into 15, and 5 is already on my list, so I know I've gotten all of the factors. Same way with 6. I know 1 times 6 are factors. 2 times 3 are factors. So now that I'm hitting 3 again, I know I've already gotten all the factors, and I'm not going to miss any if I go from the ends to the middle. So that's always how I write my lists. So you can see the factors that they share in common are 3. Okay, let's go back up here to my other example. Let's pretend like I had 12. So the factors of 12 would be 1 and 12, 2 and 6, because 2 times 6 is 12, and 3 times 4. Now, there's a lot of common factors between 12 and 24. They share a 1 in common, a 2 in common, a 3 in common, a 4 in common, a 6 in common, and a 12 in common. All of the factors of 12 are also factors of 24. But for a greatest common factor, G stands for greatest. The largest number, or the greatest number that they share together, in this case would be 12. So the greatest common factor would be 12. Between 24 and 12. In this case, 15 and 6, there was only one number that they shared in common, a factor that they share in common. So the greatest common, they do share 2 in common, but the greatest that they share in common would be 3. Okay, so you may need to be making some lists for your factors on today's stuff. It says when 2 numbers have a common factor like 15 and 6, you can write their sum as a product using the distributive property. So in this case, we knew that 15 and 6, when we look at a sum of numbers, yes, I know that that is 21, but if we think about what their greatest common factor is, in this case, we decided the greatest common factor between 15 and 6 was 3. We can use the distributive property to change how 15 plus 6 looks, and this is going to be a very important skill for you someday when you take algebra. I know 3 times 5 would be 15, and 3 times 2 would be 6. The distributive property says I take the number outside the parentheses and I multiply it by each number inside the parentheses. Again, 3 times 5 would be 15, and 3 times 2 would be 6. Okay, so this is called, we called this a multiple of a sum when I used to do it before the Ready Math series. It looks like we're just using the words distributive property right now. Okay, so if you are given 2 numbers, say, let's go with 12 plus 24. we decided the greatest common factor between 12 and 24 was 12. So I know that if I take 12 outside using the distributive property, I know that 12 times some number should equal 12. I know that 12 times 1 would equal 12. I also know that 12 times 2 would equal 24. So I know that this, how I expressed this with the distributive property, will give me the same sum as 12 plus 24. Okay? So this is explaining that. Let's do another one real quick. Let's do one that maybe you can figure out. Not too difficult. Let's do 8 plus 12. If I wanted to know the greatest common factor between 8 and 12, I could write a list of numbers. I like to go from the outside in of 8 and 12 that include all of their factors. Now, we already had a list of 12, but I can do that list again. All right, and the ones that they share in common are 1, 2, 4, and that's it. So the greatest factor that they share in common is 4. I need to know a number that would multiply by 4 to give me 8, because 4 times this number should equal 8. So I'm going to put a 2 in the first blank. And the second blank, 4 times this number should equal 12. Well, I know 4 times 3 would equal 12. So this is called a multiple of a sum. Okay, it's a different way to write your addition problems. Okay, make sure those two examples are on your paper so we can refer back to those. It says explain how you could use the greatest common factor of 8 and 20 and the distributive property to write 8 plus 20 as a product, meaning using multiplication. That means multiply. So if I thought about 8 plus 20, I would think about what their greatest common factor is. And so for today, since there's not a lot of homework problems, let's actually list the greatest common factors for each number that we're using. 1 and 8, 2 and 4. I'm just going to put 8 right there. Those are the factors of 8. And the factors of 20 would be 1 and 20, 2 and 10. 3 doesn't go into 20. 4 does 5 times. So now that I'm at 5, I already know I've gotten all my factors. I don't have to check 6, 7, 8, 9. I don't have to check those because I went from the outside in, and once I hit another number that I've already multiplied by, I can stop looking. So the numbers that they share in common are 1, 2, 4, and that's it. Those are all the factors that they share in common. I would like to use the greatest of the common factors. In this case, the greatest common factor would be 4. And that's the number that I'm going to write on the outside that I'm going to multiply by the two numbers inside. It needs to be the greatest common factor. This number should always be the GCF. Okay. 4 times this number should equal 8. I know that 2 times 4 would equal 8. 4 times this number should equal 20. I know that 5 times 4 would equal 20. Okay, if I distributed this, this would say 4 times 2 plus 4 times 5. This would say 8 plus 20, just like what we started with. Okay, this is how we would write it as a product. So in this case, this would be our solution. Okay, our answer to the question says, how would you write it as a product? It would be just like that part in green. It says the greatest common factor of 8 and 20 is 4. And we know that 4 times 2 is 8 and 4 times 5 is 20. So you can write that as 4 times the quantity. When I say that, the quantity, I'm talking about parentheses, 2 plus 5. Okay, so if I use the words the quantity, I'm talking about this part is in parentheses. All right, so that's it for today.